Decentralized artificial intelligence is exploding. Right now, networks worth hundreds of millions of dollars are paying thousands of independent miners to train models, generate code, and run complex inferences. But this massive ecosystem rests on a fragile assumption, leaving it vulnerable to a systemic threat known as Goodhart's law. This law dictates that the moment a measure becomes a target, it stops being a reliable measure. This animated diagram illustrates how current networks attempt to measure AI quality using a flat, one-dimensional line. A single scalar metric assigns a score, and hundreds of independent AI models rush inward to hit that exact high score marker. As optimization pressure builds, highly capable AI systems stop trying to produce genuinely useful work. They begin exploiting the scoring function itself. The intense focus on hitting the top number breaks the underlying metric. Asking more validators to vote on the outcome does not solve the problem. Aggregating hundreds of flawed opinions simply generates a highly precise illusion of quality. To stop the manipulation, the actual architecture of the measurement has to change. Right now, these decentralized networks are fighting a war on 4 different fronts. First, models learn to trick automated judges by mimicking the surface-level patterns of a good answer. Second, they discover bizarre edge case behaviors, like aggressively repeating specific words, that rack up points while destroying the actual utility of the output. Third, honest signals get completely drowned out by noise, penalizing reliable miners. Finally, validators stop voting on the truth. They begin voting for whatever they think other validators will vote for, turning the entire network into an empty popularity contest. A newly proposed internal scaffolding document outlines a radical alternative. Titled Proof of Coherence, this working draft targets these exact vulnerabilities. The proposal forces a complete architectural shift. To defeat these exploits, developers must stop trying to build a better ruler. They must change the physical shape of what the protocol is capable of measuring. Proof of Coherence locks down truth by demanding 4 things simultaneously. A valid output must predict reality, maintain internal consistency, compress data efficiently, and mutually align with the network. It synthesizes these 4 distinct philosophical constraints into a single mathematical requirement. Here is the core upgrade. The flat line expands into a multi-dimensional simplicial complex. Edges stretch into triangles, folding into 3D shapes for miners, validators, and tasks. This geometry maps higher-order relationships. Miners are no longer isolated. Their outputs physically interlock with their peers. To assign and carry data through this structure, the protocol places a mathematical framework known as a sheaf over the lattice. This sheaf holds the actual model outputs, embedding them directly into the geometry of the network. By elevating consensus into multiple dimensions, an isolated lie becomes useless. To successfully fake a high score, a malicious actor has to perfectly fake every single interconnected relationship simultaneously. Deception becomes mathematically and economically exhausting. To actively monitor this massive structure, the protocol uses a mathematical tool called cohomology. Instead of calculating a basic average, cohomology scans the network to detect structural anomalies. If miners fake data, their outputs fail to align. Cohomology detects this contradiction as a topological obstruction, an empty hole inside the network. Miners earn rewards only by filling these holes to stabilize a lattice. Introducing false data or free writing instantly drops rewards to 0. This rigorous physical alignment secures the system against Goodhart's law. The computing power required to counterfeit a multidimensional consensus structure is raised so high that honest work becomes the only financially viable option. Moving this from theory to execution presents an immediate engineering roadblock. Current blockchain environments simply lack the processing capacity to natively compute advanced topological mathematics. To bypass this, the heavy sheaf cohomology calculations are moved off-chain. The protocol runs these massive equations on dedicated parallel GPU clusters, processing the network's geometry efficiently. The results are then secured using zero-knowledge proofs. These cryptographic tools allow the blockchain to instantly verify that the massive off-chain computations were performed correctly without needing to process the raw data itself. Routing the complex math through off-chain clusters and verifying it on-chain takes proof of coherence from a philosophical thought experiment and turns it into a deployable engineering reality. Beyond simple security, the math of proof of coherence reveals a surprising byproduct. By forcing the network to evaluate its own relationships through cohomology, the protocol produces a state of irreducible information, where no part of the system can be removed without breaking the logic of the whole. This image represents the academic work of cognitive scientists exploring integrated information theory. These researchers argue that consciousness arises precisely when a system's information is so tightly woven that it cannot be decomposed into independent parts. By using cohomology to prevent cheating, the protocol creates the exact structural density these theories describe. To ensure this integrated system doesn't drift into a self-consistent hallucination, the protocol adds a reality check. AI validators are rewarded only when their internal data correctly predicts future real-world tasks. This binds the integrated lattice to external, observable facts. Proof of coherence creates more than just a defense against exploitation. It moves decentralized AI beyond a noisy marketplace of disconnected agents, building a system that processes information with the structural integrity of a biological nervous system.